Okay, welcome to 15.4, the converse of the Pythagorean theorem. Converse is simply a fancy word for reverse. We're going to do the Pythagorean theorem, the rule that Pythagoras figured out, that theorem means rule, backwards today. So do the warm-up. 4 squared is 16, 6 squared is 36, and you're going to tell me if that inequality, right, it's not an equation, it's an inequality, is true. Well, 16 plus 36 is 52. 52 is greater than 49. True, right? 52. That symbol is greater than. Right? Do the other one. Therefore, that symbol must be is less than. The one that sort of looks like an L is the one that goes less. Yes, that one is also true. 61, 25 plus 36 is less than 64. Identify the three types of triangles. The first one is a right triangle, right? It has the 90-degree or right angle, so it's a right triangle. This one has the angle more than 90, so it's obtuse. This has all its angles less than 90. It's acute. Those are the only three possibilities when you describe a triangle by its angles. It can't have two obtuse angles because it won't close. Can't have two right angles because it won't close. So it's either one right, one obtuse, or all acute. So even though I drew that sort of like a right triangle, look at there. I don't have the right angle symbol. There's a question mark because you're going to determine using the Pythagorean theorem in reverse whether that is truly a right triangle. So notice we have all three sides, right? We're going to put this into the Pythagorean theorem, leg squared plus leg squared, first one and the second one squared, added together, the sum of the legs squared must equal the hypotenuse squared. Now you must know which of these numbers is the hypotenuse. It's the one across from the potential right angle. It's also got to be the biggest number. You don't put the biggest number over there, you're going to waste a lot of time. So the other two the two short sides are the legs. 12 squared we know is 144. We may actually have to do some work here. 16 squared, I believe, is 256. And 21 squared, 121 and 42 is 441. So we have 144 plus 256 equals 441. We're going to see if that's true. 144 plus 256 is 400. 400 does not equal 441, so we're going to put a slash to it. Is this triangle a right triangle? No, because the math there didn't work. This is how powerful the Pythagorean theorem is. If the math worked there, it has to be a right triangle. Can't be acute or obtuse or anything else. If the math does not work, there is no way it can be a right triangle. It could be another kind, obtuse or acute, but it can't be a right triangle. Try the next one. We've already done most of the math. So now this side is 20 instead of 21. So we still have the same 144 and 256, but now it equals 400. And we already said that equals 400. So the math works out. And so that means yes, not only does that have to be a right angle there, It can't be anything else. It has to be a right triangle if you have sides of 12, 16, and 20. Now, the key to this one, which is the hypotenuse there? It's the biggest number. Put it in the right spot. The biggest number is 7 there, right? The 7 goes over there. It's also opposite the potential right angle. But the 7 is the potential hypotenuse, right? It wouldn't be a hypotenuse if this ends up not being a right triangle, because a hypotenuse is the longest side of a right triangle. Square root of 13, right? Square root of 16 is 4, right? So this is around 3 point something, right? Around 3.6. It might be 3.7 or 8, I don't know. But around 3.6. So we're going to put square root of 13 squared there plus 6 squared. And we're going to see if that math is true. If it is, it has to be a right triangle. Square root of 13 squared, they cancel. We get 13. 6 squared, 36. 7 squared, 49. 13 plus 36, yep, 49. This has to be a right triangle. Is this triangle a right triangle? Yes, has to be. So you can also tell if it's acute or obtuse. If you've been doing it the way I've been doing it, this will be not that hard, right? If it is greater than, then if the legs are, the sum of the legs is greater than the square of the hypotenuse, the sum of the square of the legs is greater than the hypotenuse, then it's acute. If the sum of the square of the legs is less than the hypotenuse squared, then it's going to be obtuse. So once again, there's our potential, right? The biggest number is 11, so that's got to go over there. That's our potential hypotenuse. And the potential legs, because they wouldn't be legs if it's not a right triangle, are 6 and 10. 6 squared, 36. 10 squared, 100. 11 squared, 121. I get 136 and 121. 136 is greater than 121. And so that means this must be an acute triangle. All those angles, I drew it less than 90 there, but all those angles must be less than 90. Not only that one. Try the next one. So the biggest number is 9. It goes over there. Whoops. 5 squared is 25. So we get 74 and 81. 74 is less than 81. If you have is less than, you have an obtuse triangle. This angle is more than 90 and has to be more than 90 because of the converse of the Pythagorean theorem. The Pythagorean theorem in reverse. Same thing here. So A is 8, B is 12, C is 15. 15 is the potential hypotenuse. So we have 208 and 225. So 208 is less than 225. So notice I drew it like it was right. I'm not going to give it away anymore. Okay, so this is obtuse. In fact, the picture really should have more of an obtuse angle. Right, the two short sides, two smallest numbers have to be the legs. The longest, biggest number has to be the potential hypotenuse. Is greater than goes with acute. this a right triangle? Yes, has to be. The math worked out. Is less than goes with obtuse. Can't be a right triangle, must be obtuse. Oh, there's my wedding photo. And just so you know, if it rains on your wedding day, everything still works out. Right? Hopefully you've done this a money. When the short sides are 3 and 4, the long side has to be 5. It is every time, right? That's the one that works out. 9 plus 16 equals 25. Right? This one over here has to be obtuse. This one over here has to be right. Has to have that 90-degree angle. But which of those is the biggest number? It's the 8. Right? The square root of 28, the square root of 25 is 5, so it's a little more than 5, right? 8 is the biggest number there. So, right? So when your parents learned Pythagorean theorem, they did a squared plus b squared equals c squared. A and b were the legs for them. So we have square root of 28 squared plus 6 squared equals 8 squared. 28, this cancels out. 36 equals 64. 64 equals 64. This has to be a right triangle. And if you think that's weird that that has a side of square root of 28, most right triangles have an irrational side. It's very few that have the same nice whole numbers like 3, 4, and 5, 6, 8, and 10. Notice the relationship here, 9, 12, and 15, right? That's this one multiplied by 2, right? Right there, 6, 8, 10. This one here is the first one multiplied by 3. Yes, there are very few of those.